Hello everyone, here we are going to see about meter bridge. What is meter bridge? So meter bridge is the using the principle of a Wheatstone bridge. As we know that in Wheatstone bridge R2 divided by R1 is equal to R4 by R3, right? The same condition we are going to use in that meter bridge. Yes. So as usual we are start from initially from the small activities, right? So this one is called I am used as meter scale. This wooden scale I used as right meter scale. So this part, okay, this part only I am using as meter scale. I am using as this wooden part, and this rope I used as for wire. So what I am going to do in the sense, so here in that meter scale the wire will be like that. Yes. Now what I am going to do, so this meter bridge is going to be here. Yes. Okay, fine. Now I have two metallic strips. So this is the metallic strip and this is the second metallic strip. So here I have one metallic strip and here I have one more metallic strip. Okay. And in between I have one conductors, right? These are all conductors. This metallic strip also conductor, this metallic strip also conductor, and here also conductor. So here we have one gap, right? Yes, and here we have one gap, right? So in that gap we are going to fix the resistors, right? We are going to fix the resistors in that gap. Okay. So here we have one gap and here we have one gap. That gap is only this gap as well as this gap, right? Yes. Yes. Can you take it? Okay. Thank you. Okay. And so here we have connected one resistance and here we are connected one resistance. This resistance is unknown resistance and this resistance is known resistance, right? So here we have metallic strip and here we have one metallic strip which is held at 90 degree perpendicular to that meter scale, right? And the meter scale is connected to battery and this side is connected to the negative terminal of the battery through key. And this is the 1 meter scale, right, 100 centimeter. And now down in that gap I have fixed unknown resistance, in that gap I have fixed one known resistance. Now what I am going to do, I am going to use one jockey. What is called jockey? So just remember that you know the knife edge, right? Yes, which has sharp edge. Similarly we will have, assume that this pen is jockey, right? So this jockey is here in that position. The one end of the jockey is connected to galvanometer. What is the role of galvanometer? Yes, to measure, to detect the current. So from this jockey we are connected to the galvanometer. The other side of the galvanometer is connected in that point B, and this is the galvanometer tip. That tip is move along throughout this 100 centimeter. It can move over this wires. It's touched with that wires, right? And what we are going to do in the sense, I am use this jockey. I move this from this end to this end, right? So initially I start from point A. Now I am slowly moving and slowly moving. At this point D, what will happen in the sense, the current flow in that galvanometer becomes 0. That means no deflection takes place in that galvanometer. So this point is called balanced point, right? In that condition R by S is equal to L1 divided by 100 minus L1 divided by 100 minus L1. So what is L1 in the sense, from the point A to D is called L1, and what is the distance between DC? 100 minus L1. Why? Because this is 100 centimeter, right? So the jockey is balanced this circuit. R by S is equal to L1 divided by 100 minus L1, right? So the jockey here is, if you are moving over this point, that time the galvanometer becomes 0, right? If you are doing practically, some may have this position or some may have this position. It depends upon these two resistance, right? Okay. And Here at this point the galvanometer shows null deflection, right? There is no current flow in that one, and that in that conditions the bridge is balanced. Now I am measuring the distance between A to D as L1 and measuring the distance between D to C is 100 minus L1, right? As from the Wheatstone bridge we know that this AC is called battery arm, right? And the BD is the galvanometer arm, right? So according to this diagram, some more explanation I have done here, and this under the principle of Wheatstone bridge, and AC is called battery arm, BD is called galvanometer arm. And here I said AD is which has a length of L1. Then what about the resistance value? Yes, R suffix centimeter into L1. So what is R centimeter? Resistance per centimeter. Here I wrote resistance per centimeter, right? So from AD will be acted as resistance, and similarly DC will be acted as resistance. We have 4 different resistors, right? That is we have seen in Wheatstone bridge. And now DC is a resistance that will have R centimeter into 100 minus L1, right? And according to Wheatstone bridge we know that R2 divided by R1 is equal to R4 by R3, or R1 by R3 is equal to R3 by R4. Similarly R by S is equal to R centimeter into L1. So corresponding their resistance, right? R1 divided by R3, R1 divided by R2, R3 by R4, or you can rearrange P by Q is equal to R by S. So under the balance condition R by S, R is unknown resistance, S is known resistance, and which is equal to R centimeter, R suffix centimeter into L1 divided by R centimeter into 100 minus L1. So here we can cancel over these two terms, and we can write R by S is equal to L1 divided by 100 minus L1, right? As we know that the L1 value, right, from the point A to D. So if you are substituting L1 value, and we can be able to calculate the unknown resistance, just cross multiply S into L1 divided by 100 minus L1. From that we can be able to calculate the unknown resistance. I hope you understand well. Thank you, and see you in the next video.